Hello everyone, welcome to my channel. Myself Sonali Gupta, and this video is about the semiconductor devices. हमने फर्स्ट वीडियो में इंट्रोडक्शन स्टडी किया है और उसकी डिस्कवरी. अगर आपने वो वीडियो नहीं देखा है आप उसे ज़रूर देखिए, उससे आपको इस वीडियो में हेल्प होगी. दिस वीडियो इज़ अबाउट द एनर्जी बैंड गैप ऑफ सेमीकंडक्टर एंड इट्स टाइप. बिफोर एनर्जी बैंड गैप we should know the structure of atom. See, every atom has nucleus and its circular orbits. हर एटम में ये स्ट्रक्चर है एटम का. इसमें जो ये सर्कुलर ऑर्बिट्स, दिस सर्कुलर ऑर्बिट्स है डिफरेंट एनर्जी लेवल्स. दिस सर्कुलर ऑर्बिट्स है डिफरेंट एनर्जी लेवल एंड दिस एनर्जी लेवल्स different for different orbits. Thus this electron has also different energy levels. The electrons which is nearer to nucleus has highest energy level compared to electron which is far from this nucleus. Means जो इलेक्ट्रॉन न्यूक्लियस के पास वाले ऑर्बिट में है उस पर उसकी एनर्जी लेवल ज़्यादा है कंपेयर टू इलेक्ट्रॉन विच इज़ फार फ्रॉम दिस न्यूक्लियस. जो इलेक्ट्रॉन न्यूक्लियस से दूर वाली ऑर्बिट में है, इट हैज़ डिफरेंट एनर्जी लेवल. Its energy level is less compared to this electron. This is the difference. And when during the formation of solid, जब हम solid form करते हैं, different atoms come close together, and that's why this energy level of electron will get disturbed. Some electron get less energy, some electron get more energy, and that's why these energy levels which the electrons which has less energy level combine together and form one band, that is valence band, and the electrons which has highest energy level, that energy levels are combined together and form conduction band. These are the two bands, valence band and conduction band. These bands form, and in semiconductor these three material are differentiated with this band diagram. This is the valence band and conduction band. See, in conduction band electrons are free to move freely. That's why they can take conduction easily. These are the conduction band, and in valence band these electrons are not freely move, but when they get energy they jump from this valence band to conduction band and start conducting. In metal, in conductor, first diagram is conductor. First diagram में band gap conductor. In conductor this valence band and conduction band both are overlap each other. दोनों ही बैंड ओवरलैप होते हैं. मीन्स कंडक्टर can easily flow electricity. In conductor electrons are freely move. That's why these two bands are overlap each other due to slightly thermal effect. These electrons freely move and they can easily conduct electricity. This is happen in conductor. ये होता है कंडक्टर में, इसलिए कंडक्टर ये इजीली इलेक्ट्रॉन्स फ्लो करते हैं, इलेक्ट्रिसिटी फ्लो करते हैं, बिकॉज इन दिस टू बैंड्स आर ओवरलैप ईच अदर. देयर इज नो गैप बिटवीन दिस टू बैंड इन कंडक्टर, बट इन सेमीकंडक्टर देयर इज द गैप. इन सेमीकंडक्टर देयर इज द गैप बिटवीन दिस टू, conduction band and valence band. This band gap is, due to this band gap, semiconductor at room temperature it behaves as an insulator. That means it cannot conduct electricity at 0 degree Kelvin temperature. But as the temperature increases due to thermal effect, these electrons jump from this valence band to conduction band, and as the electrons move in conduction band then it start conducting, and this gap is known as energy band gap. This is the energy band gap. and this is very less in semiconductor compared to insulator. But in conductor there is no band gap. Valence band and conduction band both are overlap each other, because conductor can easily move electricity. There are free electrons, and they can, due to slightly thermal effect, the electrons are free to move in conduction band. They can easily move in conduction band and start conducting. Thus it's both bands are overlap each other. But in semiconductor there is the gap between these two bands. This gap is very less compared to insulator. Insulator has more gap between valence band to conduction band, because insulator cannot conduct electricity. That's why these two band has large band gap. And this is the difference between these three band gaps: conductors, semiconductor and insulators. These are the three materials and its band gap difference. Then in insulator, see, this band gap is very large. That's why there is no conduction of electricity. Electrons cannot easily move from this valence band to conduction band. Thus insulator has very less conductivity and very high resistivity. But insulator which are used, like plastic, ceramic, in household appliances we are using plastic material. But this insulator has one breakdown voltage. If we are applying voltage to this insulator, and at high voltage, that plastic this material start conducting. At that voltage, that material break down, and that is the breakdown voltage. This breakdown voltage is different for different material, different insulator, plastic, insulator, ceramic, mica, glass. These all materials are different breakdown voltage. So their application is as per that voltage. See, in household appliances we are using plastic, but in industrial application we are not using plastic. They are use ceramic, because it has high breakdown voltage compared to plastic. These are all the insulators. So this is the band gap energy. With the help of band gap energy we can differentiate conductor, semiconductor and insulator with this band gap energy diagram. Then next topic is of its type. Semiconductor are of two types: intrinsic semiconductor and extrinsic semiconductor. In intrinsic semiconductor is pure semiconductor. Intrinsic semiconductor is pure semiconductor. In this semiconductor there is no any impurity. Here we are using only germanium or silicon or any compound semiconductor. This semiconductor, like silicon, in silicon we know silicon is tetravalent element. It has 4 electrons in its orbit, in its outermost orbit. Thus these 4 electrons form 4 covalent bonds with its neighboring silicon atom. Silicon, it has 14. 14 means 2, 8, 4. 4 electrons in its outermost orbit. Thus these 4 electrons form 4 covalent bond with neighboring 4 silicon atom. In silicon crystal, हम यहाँ पे सिलिकॉन क्रिस्टल की बात कर रहे हैं, इसमें बहुत सारे सिलिकॉन एटम कंबाइन किए. Thus this silicon form 4 covalent bond with neighboring 4 silicon atom. But in intrinsic semiconductor, pure semiconductor, as temperature increases, normally at 0 degree Kelvin temperature, it does not conduct electricity. It behaves like an insulator. But as temperature increases due to thermal effect, some electrons break covalent bond and free to move. It break this covalent bond and free to move. But when electron leaves this space, here form one hole. इलेक्ट्रॉन जब कोवैलेंट बॉन्ड को ब्रेक करेगा तो वहाँ पर वो इलेक्ट्रॉन मूव होगा in other place. Here deficiency of electron produce hole. Hole represented by circle and electron represented by E minus. See, these are the symbols. Holes represented by circle and electron represented by E minus. When due to thermal effect, this covalent bond break. Some of the covalent bond break and electron move. This electron, as electron leaves its space, there is the formation of hole. वो इलेक्ट्रॉन जैसे कोवैलेंट बॉन्ड ब्रेक करेगा और मूव करेगा, वहाँ पे डिफिशियंसी ऑफ दिस इलेक्ट्रॉन प्रोड्यूस होल. Then this deficiency, other electrons will move towards this hole and here produce space. अब यही कोवैलेंट बॉन्ड ब्रेक होगा, ये इलेक्ट्रॉन इधर मूव होगा इस होल की तरफ, तो यहाँ पर फिर यहाँ पे होल प्रोड्यूस होगा. दिस इज द पैटर्न. दिस इज द pattern of producing free electrons and holes in semiconductor, intrinsic semiconductor, because this is the pure semiconductor. Due to the thermal effect, due to the increasing temperature, some of the covalent bond breaks, some electrons move free, and due to the deficiency of that electron, they produce holes. जितने इलेक्ट्रॉन्स फ्रीली मूव होंगे उतने ही इसमें होल्स प्रोड्यूस होंगे. जितने कोवैलेंट बॉन्ड ब्रेक होंगे उतने इलेक्ट्रॉन्स फ्री होंगे उतने ही होल्स प्रोड्यूस होंगे. मीन्स इन इंट्रिंसिक सेमीकंडक्टर नंबर ऑफ इलेक्ट्रॉन्स एंड नंबर ऑफ होल्स सेम. जितने होल्स प्रोड्यूस होते हैं उतने ही इलेक्ट्रॉन्स इसमें प्रोड्यूस होते हैं इन इंट्रिंसिक प्योर सेमीकंडक्टर. And this is the pattern of conduction. These electrons start conducting. This is happening in intrinsic pure semiconductor. But this current is very minimum. बहुत बहुत कम वैल्यू होती है इस करंट की, इसीलिए फिर इसमें करते हैं डोपिंग, impurity add in pure semiconductor. When impurity is added in pure semiconductor, it produces extrinsic semiconductor. This is the second type of semiconductor. First is the intrinsic semiconductor and another is the extrinsic semiconductor. Intrinsic is pure semiconductor and extrinsic is adding impurity in pure semiconductor. This process of adding impurity is called as doping. The process of adding impurity is called doping. इस प्रोसेस को हम कहते हैं डोपिंग. इसमें इम्प्योरिटी, अब इम्प्योरिटी क्या ऐड करते हैं. सी, इन प्योर सेमीकंडक्टर इज द टेट्रावैलेंट सिलिकॉन. सिलिकॉन ये टेट्रावैलेंट एलिमेंट है. टेट्रावैलेंट मीन्स दिस इज 14. इट हैज़ 2, 8, 4 इलेक्ट्रॉन इन इट्स outermost orbit, hence it is called tetravalent. When we add impurity, one type is adding pentavalent impurity and pentavalent impurity. Pentavalent, like bismuth, antimony, arsenic, phosphorus. These are all pentavalent impurity. Means it contains 5 electron in its outermost orbit. These are pentavalent impurity. ये impurity ऐड करते हैं हम प्योर सेमीकंडक्टर में. कितनी impurity ऐड करते हैं? हम ऐड करते हैं 10⁶ प्योर एटम. 10⁶ पार्ट अगर प्योर सेमीकंडक्टर का है तो उसमें एक इम्प्योरिटी ऐड करते हैं. बहुत कम इम्प्योरिटी ऐड की जाती है. 10⁶ प्योर एटम होगा, प्योर सिलिकॉन के एटम में एक इम्प्योरिटी ऐड करेंगे. दिस इज द डोपिंग. एंड इन एन टाइप सेमीकंडक्टर pentavalent impurities add. What happened when pentavalent impurities add? This is the phosphorus atom. Phosphorus has pentavalent impurity. Means it contains 5 electrons in its outermost orbit. But it forms 4 covalent bonds with 4 silicon atoms. With neighboring 4 silicon atoms, it forms 4 covalent bonds. Pentavalent, ये phosphorus atom. Phosphorus has 285. 285 means 5 electron. 4 electron. These are the 4 electron of phosphorus atom. Form 4 covalent bond with 4 silicon neighboring silicon atom. But there is 1 electron free. Excess of 1 electron, and these electrons are free to conduct electricity. ये इलेक्ट्रॉन फ्री एक एक्सेस में है. दिस इज द इलेक्ट्रॉन एंड दिस इलेक्ट्रॉन आर फ्री टू कंडक्ट इलेक्ट्रिसिटी. Thus this impurity atom, this and this large electrons, हम 10⁶ प्योर एटम में इम्प्योरिटी ऐड करेंगे. ऐसे बहुत सारे हमको ऐसे इलेक्ट्रॉन्स मिलेंगे. ये इलेक्ट्रॉन्स निगेटिव चार्ज है, इसीलिए इसको कहते हैं एन टाइप इम्प्योरिटी. दिस इज कॉल्ड एन टाइप एक्सट्रिंसिक प्योर सेमीकंडक्टर. दिस इज नॉट निगेटिव चार्ज. ये इस पे कोई चार्ज नहीं होता है, ये निगेटिव चार्ज नहीं है, बट इट हैज़ majority carriers are electrons in this semiconductor. Hence it is called n-type semiconductor. n-type semiconductor में जो majority carriers हैं वो होते हैं electrons and minority carriers होते हैं holes. इसीलिए इसको n-type semiconductor कहते हैं. इस पर कोई चार्ज नहीं होता, ये कोई नेगेटिव चार्ज सेमीकंडक्टर नहीं है, ये न्यूट्रल ही होता है, बट इसमें मेजॉरिटी कैरियर इलेक्ट्रॉन्स होते हैं, इसीलिए इसको n-type कहते हैं. Same as in p-type. P-type we are adding here impurity trivalent impurity. Trivalent impurity means we are here the element which has 3 electrons in its outermost orbit, like boron. It is the trivalent impurity. So out of 3 electrons form 3 covalent bond with these 4 electrons with these 3 silicon atom, but there is the deficiency of 1 electron. This deficiency produce hole. This deficiency of electrons for the formation of this covalent bond, this deficiency produces hole. And these holes are positive charge particles. These are positive charge. So this is p-type semiconductor. Example, the impurities which are adding in p-type semiconductor like gallium, indium, aluminium, boron. These are the trivalent impurity. Trivalent impurity is added in p-type semiconductor. And here majority carriers are holes and minority carriers are electrons. This is the difference of p-type and n-type. Main thing is that we are two types of intrinsic and extrinsic. Intrinsic is the pure semiconductor and extrinsic is the semiconductor by adding impurity. Which impurity added? One is the n-type and another is the p-type. In n-type semiconductor we are adding pentavalent impurity. Pentavalent impurities are bismuth, antimony, arsenic, phosphorus, which has 5 electrons in its outermost orbit. These are pentavalent impurity. When pentavalent impurities are added, then out of that 5 valence electron, 4 electron form 4 covalent bond with silicon atom, but there is one free electron, and these electrons are freely available to carry electricity. And number of electrons in n-type semiconductor is more than holes. Thus, majority carriers in n-type semiconductor is electrons and minority are holes. But totally different happen in p-type. In p-type we are adding trivalent impurity. Trivalent impurity means the atom which has 3 electrons in its outermost orbit, like gallium, indium, aluminium, boron. When this trivalent impurity is added in pure semiconductor, then out of 3 electrons, these 3 electrons form 3 covalent bonds with surrounding silicon atom. But one electron, there is the one deficiency of this electron for the formation of bond, and this deficiency create hole. And this hole is the positive particle, positive charge. It has positive charge, so it is called as p-type semiconductor. In p-type semiconductor, majority carriers are holes and minority carriers are electrons. These are the two types of semiconductor: extrinsic semiconductor, n-type and p-type. These are not the negative charge or positive charge. These are only the type of semiconductor. They are neutral in nature. Actually, they are neutral in nature. They are only written because they are charge carrier, majority charge carrier. In n-type, majority carriers are electron, so it is called n-type because electron has negative charge. And here p-type, majority carriers are holes, so it is called as p-type. These are the two types of semiconductor. Then doping. Doping is the process of adding impurity. This is called as doping. This is all about the types of semiconductor. We see in this video, first is the energy band gap and then types of semiconductor. Next video is all about the p-n junction diode. So if you like it, then please like, share and subscribe.